first off, they gave a round of applause to the store, but obviously Charles helped put all this together, and Bill and everybody else. So the Aquatic Plant Club, thank you everybody for putting all this together. We appreciate it. You guys may have seen the notice on the Facebook, but I was going to be doing a talk specifically on algae, because that's something that is consistent with all of us, something we're all familiar with in very serious situations. We have to target specific aspects of our tank to try and get rid of these algae, and they're all a little bit different, although they are all weeds, and they all technically in some ways function similarly to each other. So there's preventative measures and there's specific targeting methods that we can use to get rid of them, and I'll go into kind of each one in this presentation. I'm not going to take too much of your time because obviously we're all here to swap plants and have fun and then go on about our days. So 10 minutes of your time, and then I'll get you guys back to what you want to get done today. So hair today, gone tomorrow. Very funny. Because first we're going to be talking about green hair algae. But the root of the problem, ultimately, the reason that algae grows is because we have an overabundance of some form of nutrient, right? We have a specific balance that's going to help keep our ecosystem stable, and that balance is between temperature, between light, and between CO2. And then those three aspects allow for plants to utilize the nutrients within the water column, right? So if we have an overabundance of light, or if we have an underabundance of CO2, then they can't utilize the nutrients quite as well as these weeds are able to, which have a different design so that they can take advantage of those situations where we have less than ideal plant growth. So one of the greatest and obvious triggers is going to be excessive light. Light is what pushes forward photosynthetic processes, right? So if there is an overabundance of light, then usually our plants would be extremely happy about that. They're going to plug through that photosynthetic process, but then if we have an underabundance of CO2, they can't utilize that photosynthetic process as efficiently as, say, chlorella or Oedogonium can, which is two different forms of algae. Prevention is usually most of the battle. When we kind of get to where we have stable parameters, the prevention helps keep us from having to constantly do that fight. The fight is the struggle, though, and that's what I'm going to mostly talk about today, because we can all do preventative measures, but really when people start asking questions, it's, I have an overabundance of hair algae, or black-beard algae is kicking my butt, what do I do? So we're going to talk about each one. First off, keeping a balanced fertilizer is extremely important. A lot of us love to put flourish in our fish tanks because it makes the plants really happy and we get to see that pearling. But if we're then also feeding and then we also add Flourish Advance or Trace or additional nutrient supplements, then maybe the plants aren't always getting those nutrients. Then what are we feeding, right? We're feeding the algae. And so if we can prevent excess nutrients and we balance that with how much our plants are able to utilize them, then we're not going to be feeding the algae. Strong circulation can help a lot. When we dose these fertilizers, when we dose our powdered supplements, in low flow areas, they'll gather together and then algae thrives. Sometimes our rooted plants can suck that out of the substrate, but in most cases, the large swaths of carpeting, hair algae, and other filamentation algae will take root there, will utilize the nutrients, and get out of control. So, specifically talking about green hair algae, that's that long, stringy, kind of almost slimy when you touch it type of hair algae. They're made of unicellular, filamentaceous, long strands. They do not branch off, which is why they have that kind of soft to the touch, but they're also very easy to pull up. You notice when you grab some of that hair algae and you start to pull, it pulls the whole long line with them, and that's because they're bound together at that individual platelet. And I actually have a little bit of a write-up and some of what it looks like under a microscope there, and I have a little baggie of it because, of course, it's easy to find, trust me. It's one of the more common forms of algae. This is the stuff that crops up when you've accidentally left your lights on for a day or two, or when you've added way too much food, or you added a whole bunch of new fish. That's because the excess nutrients gets out of hand, and then we haven't changed our level of CO2 or our light to compensate for that, so all of that excess nutrient value gets eaten up by the algae. So what do we do in those situations? Well, if we're going to add a lot of fish, then maybe we need to pull back that weed on our fertilizers. Maybe we need to crank up that CO2 just a touch. Now, fish do provide CO2, right? We breathe in oxygen just like fish do. We breathe out CO2 just like fish do. So, in effect, you can also bump up your CO2 by adding fish in as well. There's multiple ways to tackle that particular problem. Sometimes overstocking can be an issue. So that's not always the solution, and that's why we have those systems that dose CO2 into our tanks. But an easy way and a natural way to provide a little bit of extra CO2 without having to shell out for a regulator and a tank and everything is just by adding a few more friends to the fish tank. A little science snapshot. I talked about the unbranched filaments, but they also utilize zoospores and zygospores. And zoospores are specifically free-floating algae that explodes from the nucleus and finds a place in your aquarium to then latch on and grow out. And then we also, the zygospores are a harder, more tough platelet that sticks to surfaces, which is why it's such a nuisance. Not only can it break off, free float, and find a place, but then even if you do scrub it, that little base there is going to stick to wherever you've scrubbed at it, and then it's going to restart anew. So what we need to do is we need to control, and then we need to prevent, right? We need to take out a large portion of the algae that's causing us issue. The problem that a lot of folks do is that they get their algicides and then they just put it in the tank and hope for the best. But what that does is it causes a large die-off, which then spikes our nutrients once again, and then we're feeding that algae all for a big cycle, right? So we need to do our job and grab it out of the fish tank first, then do our treatments. So we're just taking care of that last little bit, the stragglers that are remaining, right? So how do we take care of it? Well, physically, of course, we have our mechanical. We're going to pull, we're going to brush, we're going to have our tools that suck and siphon out the algae. That's going to be the easiest ways to get rid of a lot of it. We're going to prune back particularly laden plant life that has a lot of algae on it, because sometimes it cannot be salvaged. A lot of times if we try and just pull the algae off of the plant to try and save the plant itself, we're leaving those zygospores like I talked about, right? And then boom, they grow right back. So we've got to be careful about leaving any trace of it in the tank. But any trace that we do leave in the tank can then be treated by our natural additives or fixes, like a mono shrimp. We all love a mono shrimp, right? Not the most colorful, but definitely the hardest workers, right? Also, we've got our Siamese algae eaters. I mean, it's in the name, right? They have that reticulated mouth that's great for snacking on and eating up those hair algae. American flagfish, that's actually one that I feel like people sleep on quite often because it is an awesome fish. They do great by themselves, very colorful, and they don't snack on your invertebrates or your other fishy friends. So that is an American flagfish. I see some phones coming out, so I just wanted to repeat that, make sure everybody got that. Also, cheap fish, like $8. You really can't lose with an American flagfish. Mollies also eat plants. I know a lot of people have an aversion to mollies because they do breed like crazy, so that is something to keep in mind, right? Also, boosting plant health. Healthy plants metabolize nutrients better, and they actually will sometimes put off an algicide into the water to help prevent algae from growing on their leaves, on their roots. And so at having healthy plant life, we can combat the issues that are causing the overabundance of algae. So
yeah, I heard the chemicals, the reason why if you want to do a aquascape, you just do one plant for every 3 inches.
Yeah, exactly. You don't want any dead spaces. You don't want any place where there's a high light environment, because if it hits the substrate, that's a good place for where your nutrients gather, because all of that nutrient value is falling to the bottom. If we then have it pounded by light because we don't have coverage by plants, boom, algae city, right? And starting at the bottom, that makes it extremely difficult. Right?
Yeah, carpeting plants.
Carpeting plants are the way to go for that particular issue, right? Because they've got all those roots in and within the substrate, so they're eating up that nutrient value before the algae has a chance to.
And they cover lots of area.
And they do cover a lot of area. Then, of course, as our last-ditch effort, we do have our chemical treatments, right? Excel is essentially a hydrogen peroxide mixture. And so hydrogen peroxide reacts with the water and creates a hyperoxygenated environment, which shreds the cell wall of the algae and does a really good job killing it. It also does a really good job of killing your invertebrates. So you gotta be very, very careful, right? Spot treating is ideal, using some sort of syringe or a pipette to waft it over the algae. You'll notice that within hours, it'll be brown, it'll be dead, and then our Siamese algae eaters, our shrimp and invertebrates, are a lot easier for them to eat it. It's not as tough and it's a little bit more palatable. Sometimes killing it off first will allow your more natural predators to take advantage of that situation. And then we have blackbeard algae, the infamous, everybody's least favorite. It's extremely tough, and despite its name, it's not actually a black algae, it's a red algae, a rhododendron. And it utilizes less light, and that's why we don't actually see that it's green, because it doesn't have a whole lot of the chlorophyta that's available in a lot of other algae. So they actually utilize high flow, high oxygen environments, and that's where they thrive. You'll notice that on blackbeard algae, they're always on the tips of your plant life, or they're on the outflow of your return filter, right? And that's because they utilize that fluctuation in oxygen content and CO2 to thrive. Most plants, they love that stability, and so blackbeard algae has developed a method to take advantage of that instability. And so where we may try to take away nutrient value, because that's our typical way we deal with algae, or perhaps we do a blackout of the tank, because again, that's another way we combat algae. What we end up doing is swinging our parameters in our fish tank, and that's where we see the blackbeard algae thrive. So really what you need to do is you need to pull it out physically by hand, and then just hold tight for dear life and get that tank as stable as you can. Maybe adjust where your flow is hitting in your particular tanks. Maybe even slow it down a little bit, because again, that high oxygen environment, if your flow is too high, you're not keeping any CO2 in that tank at all. That a gas exchange at the surface is gassing out all the CO2 present in your fish tank. So we talk about making sure that we have that agitated surface so our fish can breathe perfectly, but sometimes too much can gas out all of our CO2, allowing for blackbeard algae and other algae to thrive.
Yeah, and here that's the reason why a lot of people prefer those filters like sponge.
Exactly, right. Those high flow filters are great for cichlid tanks or other high oxygen environments that fish need, but in lower oxygen environments we start to see better plant growth. You see them in lakes and ponds. They thrive a lot better than fast moving rivers, right?
Yeah.
And so, the best couple of ways to deal with it, you're going to notice there's some common threads going through the rest of these algae, because despite being different, they are still all algae. They're all a type of weed. So mechanical, it's going to be pruning, it's going to be vacuuming things out, it's going to be redirecting your flow. Pruning specifically plants that are affected by it. Because of the way that they've developed, because of the way that they spread, they can actually go dormant for a long time, even if you scrape them off. So most plants, that specifically like this anubias leaf that you guys are getting passed around, it's gone. There's no scrubbing it off, there's no salvaging it. If you see blackbeard algae on a piece of your plant, just trim the whole leaf off and call it a day. You want to remove as much of the blackbeard algae as you can, because it has three methods of reproduction. It has asexual reproduction, it has asexual reproduction, and then it can also be split or mechanically divided and then spread throughout the tank that way. So very, very persistent, tough to take care of. Same thing with our Siamese algae eaters though, same thing with our Amano shrimp. They're usually touted as the only type of fish that's going to eat this type of algae, and that is true, but it's a very unpalatable algae. It's very tough, it's got a thick cell wall, so once again, we need to kill it first, and then it'll be a lot more palatable for our Amano shrimp, for our Siamese algae eaters. So get that hydrogen peroxide out, put that in a little turkey baster. This is where I'm usually going to recommend to you chemical first, because that's going to be what takes care of the lion's share of the algae, and then you can start targeting and preventing some of that regrowth, which is where we start to have that issue. But making sure that we keep those water parameters as stable as possible is going to be key on that particular one. Same chemical treatments, hydrogen peroxide, that's the way to go. Green cyanobacteria. This is going to be the last of the deep dives that I'm going to do, because this is the last of the ones that I think I see the most often, and that's really, we call it blue-green slime or green or slime algae. It's actually not an algae at all. These mats of nasty smelling green yuck are actually a bacteria. And so usually when we try and treat for them, we use algicides and hydrogen peroxide and things like that that typically treat algae, that actually isn't going to affect the blue-green slime at all. So that's why treatments like antibiotics, erythromycin, actually tackle and deal with blue-green slime way more effectively than the algicide will. Now, it has no form of asexual reproduction, so it actually has to have, sexual reproduction. So it has to have access to its biological functions to then reproduce, meaning if we do take away its light, or we do take away its nutrient value, it's going away. There's no, like I mentioned, the zygospores or anything like that earlier. Once it's gone, it's gone. But the problem is getting rid of it, because it gets down into your substrate, it gets into the actual, the soil that you have, and so usually it's almost required to, if you don't that heavily vacuum the substrate, to just take it out entirely. Low flow situation, high nutrient value, high light. That's its favorite. So as long as you can take care of that, then you should be good. A lot of times they like low nitrate. So if your tank is too clean, sometimes that's how you can start to see blue-green slime. They'll eat up the phosphate, they'll eat up the potassium, but they don't utilize nitrogen like a lot of other plants do because they are a eukaryotic bacteria. And so when you clean and clean, well, my tank is sparkling, my nitrates are 0, I don't understand, your tank is too clean. Give your plants some life, give them some nitrates so that they can start to outcompete the algae, right? Again, not an algae, it's a bacteria, treat it as such. So, aggressive siphoning and vacuuming for our mechanical treatments. That's just going to be taking it out of the tank as best as you can. I tend to waft all of my plants and then I suck the water out. That way I can make sure that it's cleaned off the leaves, and then I'm taking almost all of that water out because it's free floating in the tank. You have to be careful about that too, obviously. If you waft it off of a leaf and it goes and sticks to the back wall, you got it over there too. So just be comprehensive in your vacuuming and your water changes, right? I mentioned that erythromycin, that's an antibiotic. There's also Fritz Marison's Maricin 2, which is another antibiotic. That treats the tank for bacteria, and so because this is a eukaryotic bacteria, you can watch it very easily start to dwindle away. So that's a good treatment on the chemical side of things. Maybe once you've done all of that physical pulling out, treat it with that erythromycin and it is gone. That is our go-to when we treat blue-green slime. Nothing eats it, so you will never get a fish or a shrimp or a snail that's going to get rid of it. You're just going to have to redirect your flow, manage your nutrient value, lower your lights, and then ultimately it will go away on its own.
Is it true that you can have a good bacteria outcompete it or something?
There are anaerobic bacteria that do munch on it, but usually if they're thriving, then there's something else present in your tank that's causing it to do well. So they do well in a low oxygen environment, so you'll probably recognize that your fish aren't doing quite as well either. So yes, true, but not ideal. Then we have the last couple. These are just going to be some quick hits on a couple of other things that we can see in the tank, and then we'll let you guys get your plant swap done. So these are the rest, as I'm calling them. I was going to show you guys some green water, but I see somebody brought some that looks way better than mine, so we can just use that as an example. So brown diatoms are kind of a new tank syndrome issue. They thrive in a high silicate environment, so usually your brand new substrates, all your new rock is feeding these diatoms. This is usually the algae we see when we have new tank syndrome, right? It's brown, it's dusty, it covers everything, but it's pretty easy to clean up. That stuff goes away on its own, and shrimp and snails love to eat it. So I would just take that as this is my new tank. It's kind of going through its thing, but I'm not going to do anything to the tank itself, because once I start messing with it and we start to get those swings, then we start creating other algae that we don't want to deal with. Diatoms are not too scary as long as we do our job in vacuuming them out and we give the tank plenty of predators for those diatoms. We should be good. Dusty, brown, that's kind of what we're thinking of when it comes to brown diatoms. There's also green spot algae. You probably recognize green spot algae from when you wipe at your tank, and those little spots are still there at the very bottom usually. And you sit there and you scrub and you scrub and you end up having to get a razor blade to finally scrape those off. Those are just a radial disc that spreads almost like a mold as opposed to growing out like a green hair algae. So it has a very hard chitinous sort of cell wall that makes it very difficult to treat, which is why physical manual removal is just going to be ideal. It doesn't grow very quickly, so once you've scraped it off with a razor blade, it's unlikely to come back. But don't let it get out of hand, because that's when it gets really tough to get. And then we've got green water, which is what I mentioned over here. It's like chlorella or chlamydomonas algae that are a free-floating planktonic algae. UV sterilizers knocks that out like nothing. So you would probably want to get something that goes inside of your tank and runs your tank by a UV light, and that sterilizes any free-floating bacteria and algal cells that are in the water. So that pea soup that you kind of see every once in a while, again, if you left your light on for a couple days by mistake, UV sterilizer knocks that out, no problem. All right? Yes, some positive messages. Yes, your tank can be algae-free. It's not too difficult. We just got to make sure that we maintain those parameters and we keep stability at our most highest priority, right? We're not going to try and treat the algae. We're going to try and treat the tank like it's an enclosed loop or an environment all on its own, and then the algae will naturally work its way out. Plenty of plants, lots of CO2, good lighting, and we won't have any algae issues whatsoever. Any questions? Over here?
No, here.
All righty. All right, well, have fun, guys. I'm glad you guys listened to me talk. I'm going to leave these out in case anybody wants to get another